Okay, example number 3. This one is about a sports car passing a patrolman, and the patrolman uses his speedometer, and he's going 50 miles per hour. 4 minutes later, he passes another patrolman, and he has gone a total of 5 miles. 5 miles, those patrolmen were 5 miles apart, and they noticed that he was traveling 55 miles per hour, and they're wondering if the patrolman can use the mean value theorem to prove that the driver was exceeding the speed limit of 70 miles per hour at some time between the 2 mileage markers. And so what we need to do is we need to calculate the average speed of the sports car on the time interval from 0 to 4 minutes. Notice that everything is in hours. Miles per hour here, miles per hour here, miles per hour here, but this is 4 minutes. So the first thing we need to do is change our 4 minutes into hours. So to do that, we would multiply by 1 hour over 60 minutes. And of course our minutes cancel, and that's going to give us 4 over 60 hours, which reduces to 1 over 15 hours. So the time interval is 1/15 of an hour. So we are going to say that if you want to think about it, here is the first patrolman, and that's going to be at our time t equals 0. And then here's our second patrolman, and that's at the time t equals 1/15 of an hour. And we're going to let t equal the elapsed time in hours after the car passes the initial patrolman. And we're going to let s of t equal the distance in miles from the first marker at time t. And so our velocity average is going to be our s of 1/15 minus our s of 0 divided by 1/15 minus 0. Now that's going to be our change in distance divided by our change in time. And our change in distance, they said, was 5 miles because the patrolmen were 5 miles in between one another, right? There was a distance of 5 miles, it said, divided by our 1/15 of an hour means that he was going 75 miles per hour. So that means at some point he was traveling 75 miles per hour. So the officers can use the mean value theorem to guarantee that at least one point in those 5 miles that car was traveling at 75 miles per hour. So yes, by the mean value theorem, the car was traveling 75 miles per hour at least once on 0 to 1/15 of an hour time interval. Okay, example number 4. For that one, let f of x equal 5 minus 4 over x. Find all values of c in the open interval 1, 4 guaranteed by the mean value theorem. So at 1, it looks like the function is at this point 1, so that would be the point 1, 1. At 4, it looks like the function is at 4, so that would be the point 4, 4. So we would be calculating the slope of the secant line, it's your average rate of change, and we want to find out, is there some value, in here somewhere such that the slope of the tangent line is parallel to that. And as you can see on our closed interval from 1 to 4, it looks like it's continuous and differentiable. So I would say, number 1, f of x is continuous on the closed interval 1, 4. Number 2, f of x is differentiable on the open interval 1, 4. And the third thing I would do is I would calculate f prime of x. And so derivative of 5 is 0. Derivative of negative 4 times x to the negative 1 would be positive 4 x to the negative 2, which would be positive 4 over x squared. And then we want to show it as f prime of c, and that would be positive 4 over c squared. Our fourth thing would be to calculate f of 4 minus f of 1 divided by 4 minus 1. That is the slope of our secant line. And our f of 4 we said was 4 minus our f of 1 divided by 3. So 3 divided by 3. So the slope of our secant line is 1. So we want to know for what value of c is the slope of the tangent line 1. So now we're going to take our f prime of c and set it equal to our f of b minus f of a over b minus a, just like it says in the mean value theorem, okay? So our f prime of c is 4 over c squared, and we're going to set that equal to 1. And so our c has to be plus or minus 2, because 4 over 4 is 1. How would I get 4 down here? That would either be positive 2 squared or negative 2 squared. There's only one that is in our interval, though, so we are only going to focus on the one that is in our interval, c equals positive 2. And so that is going to be where the slope of the tangent line is equivalent to the slope of the secant line, and where they are parallel. And so by the mean value theorem, which guarantees at least one value such that the slope of the secant line is the same as the slope of the tangent line. And so at c equals 2 is where it happens. All right. That leads us to example number 5. And it says find all values between the x-intercepts for which Rolle's theorem holds for the roots of f of x equals 4x squared minus x to the 4th. Verify with your calculator. So first I think of this function, f of x, as a polynomial. Function that is continuous everywhere. And thus is continuous well, it doesn't really give us an interval, sorry. We can just say that it's continuous everywhere, period. And number 2, f of x is differentiable everywhere also. So it doesn't matter what interval they give us, it's continuous and differentiable. So number 3, we would calculate our derivative. And the derivative would be 8x minus 4x to the third. And since they want to find here x-intercepts, we know that x-intercepts on a function is where it crosses the x-axis. So this is where f of x crosses the x-axis. And on the x-axis, all y values are 0. So we can say all y values are 0 on the x-axis. So if I want to know for what values are my y values 0, that is where my f of x equals 0. So my 4x squared minus x to the 4th equals 0. I'm going to factor out x squared. That is at x equals 0 and x equals plus or minus 2. So that means that f of negative 2 is the same as f of positive 2 is the same as f of 0, and they're all 0. And so it says, find all values between the x-intercepts for which Rolle's theorem holds for the root. And so we're talking about from negative 2 to 0 and from 0 to 2. So our function, if you put it in your calculator, it's going to give you a function that looks like this. And I know that my drawing is not very good because it doesn't look very, we're just going to start all over on that one. It looks something like this. And this would be my 2, my 0, and my negative 2. So you can see that at those points, I have x-intercepts there.